Hey guys, it's Dr. B here. Today is April 21st, 2020. Your molality homework is due today. We have a new lecture, and your new homework will be due on April 24th. So we are covering 3 of the 4 colligative properties listed here on the front. So we'll cover depression of the freezing point, which means that solutions will freeze at lower temperatures than the solvent. So by adding solute, the temperature to freeze this solution now will drop more. Conversely, the boiling point goes up, it elevates. So adding a solute to a solvent will make the solution boil higher than what it normally does by itself. Depression of the vapor pressure, we won't cover that. And the last one, osmotic pressure, we will cover. So it's the pressure required to achieve something called equilibrium to stop osmosis. Alrighty, so depression of the freezing point. You'll notice that each of these are going to have some kind of comic booky related stuff, so definitely know it's me. Alrighty, so depression of the freezing point. Solutions will freeze at lower temperatures than the solvents used to prepare them. So for example, antifreeze, ethylene glycol right here, C2H6O2. So this most likely will be a non-electrolyte, and therefore the Van Hoff factor will be 1. Remember that from the last lecture. When it's added to the water in the radiator of a car, this actually will decrease the freezing point of the water itself. So this is what they use in your car to keep it from freezing, if you will, when the temperature drops. So if you look over here, right here, so if you add Prestone, what happens is that the temperature will drop as you're adding more solute to the solvent. So that mixture solution will decrease the freezing point so your car won't freeze over. Another example of decreasing the freezing point, is salt, calcium chloride when they put that on the roads. When it's iced or snowed over, whatever, the solution it makes will make the ice liquid, if you will. So it's not really melting per se. It's more like it is decreasing its freezing point. So when it becomes liquid, it's not as slippery or slick as driving on ice. So that's what is happening there. Next time you're driving, you see like they de-ice the roads, put salt on the roads, etc. That's what's really happening. It's not melting the ice per se, it is just decreasing the freezing point of it, so it goes back to liquid. Alrighty, so how to calculate depression of the freezing point? Delta TF. So remember, delta means heat, but also means change. So the change in the freezing temperature. It is delta TF equals KF times lowercase m times I. So KF is a freezing point constant, and I will give that to you. Molality from last week. Remember, it's moles of solute over kilograms of solvent. And I is your Van Hoff factor that we talked about last lecture. So to find the new freezing point, you have to take the freezing point of the solvent, which I will give you, or something you should know, and subtract the delta TF to get your new freezing point. And your units will be degrees Celsius that you're working with for temperatures. Okay. First question, at what temperature would a 0.5 molal methyl alcohol solution in water freeze? So the KF, your constant for water, is here, 1.86 degrees Celsius over per molality. Methyl alcohol is a non-electrolyte, so that means the Van Hoff factor will be 1. So you have to solve for delta TF first. So delta TF equals KF times molality times I. So 1.86 degrees Celsius over M times 0.50 M times 1, the Van Hoff factor. So 1.86 times 0.5 times 1, that is 0.93 degrees Celsius. So this is in water. The freezing point of water is 0 degrees Celsius. So you have to subtract your delta TF. Therefore, your new freezing point would be a negative 0.93 degrees Celsius. That is your temperature right here. You've calculated delta TF, which is the change in freezing point or the depression of the freezing point. So it depends on what I'm asking for. You got to pay attention to that. All right, what is the freezing point of a 0.5 mol solution? 0.5 mol NaOH solution water, Kf is 1.86 degrees Celsius over M. NaOH is an electrolyte. So remember sodium, then OH. So that is two different things. So it's going to be two different ions, Na plus and OH minus. So your Van Hoff factor will be 2. So delta TF equals Kf times M times I. So 1.86 degrees Celsius over M times 0.5 times 2 for that Van Hoff factor. So 1.86 times 0.5 times 2 is actually 1.86 degrees Celsius. So the new freezing temperature for this would be, because it's water, 0 degrees Celsius minus 1.86 degrees Celsius, and your new freezing point will be negative 1.86 degrees Celsius boxed in. Okay.